Binomial Theorem, sheet 1. Have you been able to solve all problems? Did we solve problem 12 in the class? C0 squared minus C1 squared plus C2 squared. We've solved. 13. $14. No. Obviously, like we've always been doing, we expand 1 plus x power n conventionally and then check on what we need to be doing. See, one of the things that we need to obtain is, this is like C1 plus 2 into 2C2, 3 into 3C3, 4 into 4C4, n into NCN. First, figure out a way of obtaining 1 into C1, 2 into C2, 3 into C3, n into Cn. Let's figure that out. And obviously, one way to obtain that is by differentiating this with respect to x. You will have C1, 2C2, 3C3, NCN. Yes or no? Right? Differentiate one time. So when I differentiate once, I get n into 1 plus x power n minus 1 as C1 plus 2C2x plus 3C3x squared NCN x power n. Yes or no? X power n minus 1. Right. Now, realize that we needed a 2 squared here. We needed a 3 squared here. We needed a 4 squared here. We needed a n squared here. Right? It would have been so good if this was x squared, because then when I differentiate again, I would have got a 2 squared. It would have been really nice if this was x cubed. Then on differentiating, I would have got 3 squared. It would have been so nice if this was x power 4. I would have got 4 squared on differentiating. X power n, then I would have got n squared, right? So then, if it's not that nice already, we can make it that nice. We multiply throughout by x and we'll be able to produce the required pro forma, yes or no? So let me multiply throughout by x. So n into 1 plus x power n minus 1 into x is C1x plus 2 squared C2 2C2x squared plus 3C3x cubed NCN x power n. Yes or no? And now the ground is ready for us to obtain a 2 squared, a 3 squared, a n squared. Why? Because if I differentiate subsequently, I get C1 plus 2C2, 2 squared C2 into x, 3 squared C3 into x squared, n squared Cn into x power n minus 1, and we'll be all set. Right? So now, see, in this case, this is product of two functions. So I'll apply the product rule of differentiation when I differentiate with respect to x. So then we end up getting into derivative of this into this plus derivative of this into this. Derivative of this with respect to x is going to be n minus 1 from chain rule, 1 plus x power n minus 2 into x plus derivative of x, which is 1, into this. Yes or no? Which then must be C1 plus squared C2x plus 3 squared C3x squared plus n squared Cn x power n minus 1. Yes or no? Just to simplify matters, you could take like a 1 plus x power n minus 2 common from this. So if you took 1 plus x to the power n minus 2 common from the whole thing, then you get n minus 1 into x plus 1 plus, yes or no? Right? So, which is only nx plus 1, which is only nx plus 1. Now, to get the value of C1 minus 2 squared C2 plus 3 squared C3 and plus n squared Cn, etc., what would you do? Put x equal to minus 1. Put x equal to minus 1, you get C1 minus 2 squared C2x plus 3 squared C3 x squared and so on so forth. Put x equal to minus 1. If you put x equal to minus 1, this becomes 0. So this becomes 0 on plugging in x equal to minus 1. How about it? Very simple. Got me? (23) part 1. (23) part 1. C naught by A minus C1 by A plus 1 plus C2 by A plus 2 minus etc. Cn by A plus n is this. Anyone who got this right? Anyone who's got this problem right? How many of you have attempted this problem? Okay, 1, 2, 3, 4, 5, 6, 7. Now, this is identical to this. This is what we want to show. That means true for all values of A. All values of A. What I do is, I take this expression, the right hand side expression, n factorial by A into A plus 1 into A plus 2, A plus n. That's equal to, now what I do is, I write this as A naught by small a plus A1 by A plus 1, A2 by A plus 2, An by A plus, where A0, A1, A2, A3 are undetermined coefficients. A0, A1, A2, An are undetermined coefficients. I call these ARs as undetermined coefficients. And this is identical to this if I can show eventually. A0 is C0, A1 is minus C1, A2 is C2, A3 is minus C3 and so on and so forth. Then my problem is solved, isn't it? In a very general sense, then if I can establish that AR is minus 1 to power r CR. Then the problem is solved. Where CR is NCR. Where CR is NCR, isn't it? If I can establish that AR is minus 1 to power r CR for r equal to 0, 1, 2, etc., then the problem is solved, because then A0 will turn out to be C0. A1 will turn out to be minus C1. A2 will turn out to be minus C2. A3 will turn out to be C2. A3 minus C3, and so on and so forth. Yes or no? So if I can establish AR is minus 1 to power r CR, then the problem is solved, right? Now what I need to exploit here is the fact that this is an identity and it's true for all. I can judiciously supply values of A on both sides and obtain the coefficients A0, A1, A2, AN. That's the blueprint. You know what I'm saying? Let me multiply it throughout by the denominator. Let me multiply it throughout by the denominator. Then I have n factorial equal to A0 into, see, this A will get cancelled with this A, and I'll have like A plus 1 into A plus 2 into A plus n, right? Plus A1. Now A plus 1 will get cancelled, right? So then in the resulting expression, A plus 1 will be missing. A plus 2 into A plus 3 and so on and so forth with A1. And with A2, in the product, A plus 2 will be missing. So A into A plus 1 into A plus 3 into A plus n. Yes or no? Right? And in a very general sense, with AR, what would be missing in the product? A plus R. A plus R would be missing in the product. So that's going to be AR into A plus 1 into A plus 2. Just prior to AR would have been A plus R minus 1. Just after A plus R would have been A plus R plus 1 into A plus R plus 2. A plus R plus N. A plus N. Right? All the way to N. And so on and so forth. Yes or no? So, what I'm trying to eye is AR. And in AR, realize that A plus R is missing. A plus R is missing. And in all other factors, A plus R is present. Yes or no? So if on both sides, if this is an identity and if I plug in A equal to minus R on both sides, if I plug in A equal to minus R on both sides, all other terms, this will become 0 because it has a factor A plus R. This will become 0 because this has a factor A plus R. This will become 0 because it has a factor A plus R. Except this term, this would be the lone residual term when I plug in A equal to minus R on both sides. Yes or no? Right? So that would be the key to solving the problem. Plug in A equal to minus R. So if I plug in A equal to minus R on both sides, then I have n factorial equal to AR. So only this term will remain, right? Minus R into minus R plus 1 into minus R plus 2 minus R plus R minus 1 minus R plus R plus 1 minus R plus R plus 2 minus R plus n. Yes or no? Clear? Now, do you realize that from this point to this point, from this point to this point, this is minus R plus 0, minus R plus 1, minus R plus 2, minus R plus R minus 1. How many terms are there? R terms are there. R terms are there, yes or no? There are R systems, see, minus R plus 0, minus R plus 1, minus R plus 2 and minus R plus R minus 1. So 0, 1, 2 up to R minus 1 will give me R terms in the product here. Now, if I took minus common from each of them, then I'll get minus 1 to power r. If I took minus common from these terms, what would I get? AR minus 1 to power r, and then I have like a r into r minus 1 into r minus 2 to 1, because this would become plus 1, right? Yes or no? As far as these terms are concerned, see, minus r plus r0, so 1 into 2 into 3 up to n minus r, isn't it? These terms, starting from here, 1 into 2 into 3 up to n minus r, yes or no? That will give me n minus r factorial, that will give me n minus r factorial, how about it? Right. I hope all of you understand this. So, into n minus r factorial. And the left hand side is n factorial. Yes or no? And from here to there is what? 1 into 2 up to r is r factorial. So then I get ar equal to n factorial divided by n minus r factorial by r factorial minus 1 to power r. Yes or no? What is this? NCR. And minus 1 to power r, whether it's sitting in the denominator or it's sitting in the numerator, it will impart the same sign, isn't it? Does not matter. It could be moved to the numerator, right? So that's minus 1 to power r NCR. Which was our objective? Which was our objective? Yes? Got me? Fair enough? Look at the sheet titled Next Step. All of you have the sheet titled Next Step? You have the sheet with you? No? Okay. Okay. Passage 2, all of you. Passage 2. How many of you have attempted this passage? Okay, 1, 2, 3, 4, 5, 6. Okay. Sheet titled Next Step. Passage 2. We have 1 plus x square whole to power 20. We want to be able to find the value of A19. Now, even before I randomly start solving the problem for you, try and understand what lies beneath. Why a naught plus a1 plus a2 plus a19? I mean, how is it possible to find a naught plus a1 plus a2 up to a19? Perhaps that could be the reason. Now, another thing that you want to observe in the options is that no, in A and B, for example, the options involve a A20. It means this perhaps has to be written in terms of A20. All right. Now, keeping that as a blueprint, let's see what lies in the mind of the person who set this problem. All right. If I look at the set of terms, A19 x power 19, then A20 x power 20, and then A21 x power 21, A22 x power 22, A40 x power 40. Now, in the whole thing, if I plug in x equal to 1, I get 3 to the power 20 equals a0 plus a1 plus a2 plus a19 plus a20 plus a21 plus a22 plus a23 up to a40 is what I get. Chances are that a40 turns out to be the same as a0. A39 turns out to be the same as a1. A38 turns out to be the same as a2. Now, if that happens, then a0 plus a1 plus a2 plus a19 plus a21 plus a22 up to a40 would be twice a0 plus a1 plus a2 plus a19. Yes or no? You know what I'm saying? So, if I can establish, or at least try and establish, that a40 is the same as a0, a1 is the same as a39, a2 is the same as a38. Right? In a very general sense, if AR is A, N minus R, if I can establish that, then this would make sense. This would make sense. Right? A20 would be isolated, then twice of A0 plus A1 plus A2 plus A19 could have been written in terms of A. Right? Now, just take one step back. And go back to binomial theorem. How I started binomial theorem, right? I started binomial theorem by saying 1 plus x power n is a0 plus a1x plus a2x squared plus anx power n, right? This is how I start binomial theorem, where a0, a1, a2 were all blind alleys for me, were unknown, right? I didn't have any knowledge of a0, a1, a2, a3. It was much later that I figured that a0 is c0, a1 is c1, and so on. But eventually, even without what a0, a1, a2, an were, could I have established that a0 is the same as an, a1 is the same as an minus 1, a2 is the same as an minus 2. I could have established that. If you recall, how I did that was I replaced x by 1 by x. I replaced x by 1 by x. And then 1 plus 1 by x whole to power n was a0 plus a1 by x plus a2 by x squared plus now multiplying throughout by x power n, I get 1 plus x power n equals a0 x power n plus a1 x power n minus 1. Please switch off the mobile. Plus an? Yes or no? Now 1 plus x power n is this, is also this. See, what's the coefficient of, so this expression and this expression must be identical. What's the coefficient of x power n here? An. What's the coefficient of x power n here? A0. So an has to be a0. What's the coefficient of x power n minus 1? an minus 1. What's the coefficient of x power n minus 1? A1. So an minus 1 is a1 and so on and so forth. Yes or no? So this was the ideology in establishing that coefficients of terms equidistant from the beginning and end were equal. Yes or no? Right? This is how this was the whole idea, right? And you know, and by this time, I didn't even know that A naught was C naught, A1 was C1, and so on and so forth. We didn't have to know that at all, right? So, given some basic that came to us at the time we started our journey in binomial theorem could be exploited in this same thing. You could then in this plug in x equal to 1 by x. You could plug in x equal to 1 by x. So if you plug in x equal to 1 by x, whole to power n, that's a naught plus a1 by x plus whole to power 20. On multiplying throughout by x power 40. Multiplying throughout by x power 40. A40. Yes or no? Hey, this 1 plus x square same as this. That means this expression is identical to this expression. Yes or no? So this is the same as a naught plus a1x plus a2x squared plus a40x power 40. How about it? Now, what's the coefficient of x power 40 here? A naught must be equal to a40. What's the coefficient of x power 39 here? A1. What's the coefficient of x power 39 here? A39. A1 equal to A39. Similarly, A2 would be equal to A38 and so on and so forth. Do you realize that? So, AR in general is AN minus R. AR is the same as AN minus R, which we predicted. In order that this could be found. That was the rationale behind that prediction. Clear? Now, good for us, things turned favorable when we replaced x by 1 by x. In most cases, I'll tell you, whenever you have to establish AR equal to A n minus R, then x equal to 1 by x will do the trick for you. Invariably, x equal to replacing x by 1 by x will take care of things, right? Which happened here also. Okay. Now, of course, as was warranted, let me plug in x equal to 1 on both sides. So if I plug in x equal to 1 on both sides, I get 3 to power 20, right? Equals A0 to A19, and this is A20 to A40. So A40 same as A0, A1 same as A39. So this would give me twice A0 plus A1 plus A19 plus isolated A20, unpaired A20. So this is like twice A0 plus A1 plus A19 plus A20, right? And then I get A0 plus A1 plus A19 equals 3 to power 20 minus A20 by 2. Yes or no? Right? Now, once we go past this first stage, look at part 24 of the same problem. 24, the value of I want to be able to find the value of this. Again, I want to club A0 with A40. So this will give me 82 A0. Yes or no? Because A40 is the same as A0. So this will give me 82 A0. A39 is the same as A1. 82 A39. Yes or no? So A1, I want to write this as A1 plus A2, and everything gets paired up to A19. And then there is an isolated A20. There is an isolated A20, and the coefficient of A20, as you can see here, is 41. A41 would be the coefficient of A20. A20, see, this is 2 into 1. This is 2 into 2 plus 1. This is 2 into 39 plus 1. This is 2 into 40 plus 1. So 20, we have 41. A into this 2 into 20 plus 1, A41. Yes or no? Yeah, 41, A20, right? And A0 plus A1 plus A2 plus A19, we've already figured out. 3 to the power 20 minus A20 divided by 2, right? The first part of the problem was, this is 3 to the power 20 minus A20 divided by 2. And this is 41. And 41 A20 will get cancelled with 41 A20 here, leaving you with 41 into 3 to the power 20. Right? Look at 23. Look at 23. I hope all of you got it right. Find the value of A0 squared minus A1 squared plus A2 squared up to minus A19 squared. This again, if you remember one of the problems that I solved from the previous sheet, C0 squared minus C1 squared plus C2 squared minus C squared. The same philosophy will get extended into this. The same idea would get extended into this. What I do here is, first of all, let me create a scene where I could have alternate signs, and I could replace x by minus 1 by x. I could replace x by minus 1 by x in this mother expression. If that, then 1 minus 1 by x plus 1 by x squared whole to the power 20. Replacing x by minus 1 by x. That's a0 minus a1 by x plus a2 by x squared. Yes or no? Now on multiplying throughout by x power 40, on multiplying throughout by x power 40, This is what I get. Now let me multiply these two. When I multiply these two, I'll get like a naught squared as one of the terms, minus a1 squared plus a2 squared. Those terms will become available then. The one that are required in this. Yes or no? Right? So when I multiply this with this, whole to power 20, that's equal to yes or no? Now, how do I obtain a naught squared minus a1 squared plus a2 squared coefficient of x power 40? Do you realize that? A naught squared x power 40 minus a1 squared x power 40 plus a2 squared x power 40 minus a3 squared x power 40. Right? Yes or no? Right? So that means on the right hand side, a naught squared minus a1 squared plus a2 squared minus a3 squared a40 squared, that appears as coefficient of x power 40 on the right hand side. That is how it is. That appears as coefficient of x power 40 on the right hand side, which in turn must be equal to coefficient of x power 40 on the left hand side. Right? That means all that I need to do is I need to find the coefficient of x power 40 here. I need to find the coefficient of x power 40 here. One of the things that of course you can again do is you can up to a19 squared and then a20 squared, and all others would get added up. A same as a40, be the same as a39. So this actually is twice a naught squared minus a1 squared plus a2 squared minus a3 squared minus a19 squared, right? And then there would be an isolated a20 squared. Yes or no? Right? And this actually would be equal to coefficient of x power 40 on the left hand side, which is this, right? So I'm seeking coefficient of x power 40 in this. This you realize 1 plus x squared plus x into 1 plus x squared minus x. A plus b into a minus b is what? 1 plus x squared whole squared minus x squared whole to power 20. This is 1 plus x power 4 minus x squared plus x squared whole to power 20. Yes or no? Right? So in this, what am I seeking? Coefficient of x power 40 in the expansion of this. I'm seeking coefficient of x power 40 in the expansion of this. How about it? X power 20, x power 40 in the expansion of this. Clear? And that will be equal to this. That will be equal to this. Coefficient of x power 40 in this will be equal to. Now, look at this. 1 plus x squared is this. Huh? In this, replace x by x squared. Right. Replace x by x squared so that you get this expression. Yes or no? Right? So if you replace x by x squared, you get 1 plus x squared plus x power 40 whole to power 20 is a naught plus a1x squared plus a2x power 4 plus a20x power 40, isn't it? See, they are all double. So a22x power 4, a3x power 6, a20x power 40, and so on and so forth. Isn't it? So what's the coefficient of x power 40? A20. A20. Yes or no? Coefficient of x power 40 is A20. So this then must be A20. So this, the required summation S would be A20 minus A20 squared divided by 2. That's the required, this is S, the required sum. A0 squared minus A1 squared plus A2 squared minus A3 squared, etc. S is A20 minus A20 squared by 2. Aha. Don't get so petty about this. I mean, it's a typo. Don't bother about typos. When you know I was seeking 1 plus x squared plus x power 4. So with that objective, I replace x by x squared. So had to be x power 4. So if I end up writing x power 40 or x power Jumri Talaya, don't read too much into it. You know that I meant x power 4 only. Right? So got me? You know, what comes to us by means of this problem is like a variety of situations in binomial theorem which use this kind of a thing, So it's very important that you breed familiarity with what I just did. You know, whatever I did in terms of this problem is the framework for a large variety of problems. And you'll realize, you know, the situation in which you want to establish AR is A n minus R and replacing x by 1 by x, these are common practice things in binomial theorem. So get yourself some mental comfort with this, right? Come back to sheet 1. 15. Who did problem 15 right? Have you attempted this problem? Problem 15. C1 minus C2 by 2 plus C3 by 3 minus 1 to power n minus 1 Cn by n. We want to show is 1 plus half plus 1/3 and so on and so forth. Now this seems like a very, very sticky situation, you know, to get the sequence out of this summation. It doesn't fall necessarily within, you know, the kind of things I taught to you in binomial theorem. I mean, yet there is something that you can learn out of solving this problem, which would give you yet another premise for problem solving in general in mathematics, you know. Realize again, I'll make you solve this problem. I'll induct you into this situation, right? This is all like NC1, NC2, NC3, NCN by N, etc. Right? And I'll tell you two ways of doing this. The easier way of doing this is to use calculus. But then, you know, there is a situation which you've not learned, but I'll still solve it using calculus, but that's an easier thing and I'll do it after I solve it without calculus for you. After I make you solve it without calculus, then I'll show you how to do it with calculus. Now, do you realize that if I choose to call this expression, just this expression, as some un, and I can establish, if this is un, then what would un minus 1 be? Un minus 1 would be n minus 1 c1, n minus 1 c2 by 2, n minus 1 c3 by 3, minus 1 to power n minus 2, n minus 1 cn minus 1 by n minus 1. That would be un minus 1, yes or no? Un minus 1 would be like a n minus 1 c1 minus n minus 1 c2 by 2 plus n minus 1 c3 by 3. That's un minus 1. Now, right, if I can establish one thing, you would then expect un minus 1 to be, if this was un minus 1, you would expect un minus 1 to be 1 plus half plus up to 1 by n minus 1. If un turns out to be 1 plus half up to 1 by n, then un minus 1 should turn out to be 1 plus half plus up to 1 by n minus 1, yes or no? Which means un minus 1 turn out to be un minus 1 should turn out to be 1 by n, because the terms prior to this would be 1 by n minus 1, we cancel well all terms here, right? So if I can establish that un minus 1 is 1 by n, if I can establish that un minus 1 is 1 by n for all n, then if somehow I can establish this expression minus this expression is 1 by n, then see what happens. Plug in n equal to 2, for example. I have u2 minus u1 is 1 by 2. Plug in n equal to 3, then I should get u3 minus u2 is 1 by 3. u4 minus u3 is 1 by 4. un minus un minus 1 is 1 by n. And u1 is 1. And now if I add vertically, there is a quick cancellation, telescopic cancellation of terms, leaving you with two virgin terms, un and u1. u1 is 1. Plugging n equal to 1, there would be just one term, 1c1, that will be 1. Then un minus 1 is half plus 1/3 plus 1/4 plus 1 by n. Un then would turn out to be 1 plus half plus 1/3 plus 1 by n, yes or no? You know what I'm saying? So then, the blueprint of the solution is there with us. The bigger problem has reduced to a smaller problem. The bigger problem is this. The smaller problem is, choose un as this expression, un minus 1 then would be this. And then if I can show that un minus 1 is 1 by n, and then by plugging in n equal to 1, n equal to 2, 3, 4, etc., I can get a telescopic cancellation and I'll be able to obtain un. I'll be able to obtain un. Yes or no? Right? So then this problem has been redefined. Redefined, that is, this is my equivalent problem. If I do this, then it'll be good for us. Yes or no? Yes or no? Right? Now again, I'll do one more step and then I'll move around in the class to help you out with things here. Right? One of the things here is that there are n terms here and there are n minus 1 terms. Yes or no? When I do a un minus 1, what is it that I get? Un minus un minus 1, I get nc1 minus n minus 1, right? Minus nc2 minus n minus 1 c2 by 2 plus nc3 minus n minus 1 c3 by 3 up to see the term just before this would be what? The term just before this would be minus 1 to power n minus 2 nc n minus 1 divided by n minus 1 would have been the term just prior to the last term. And this would get clubbed with this. This then would be a leftover term. This then would be a leftover term, which is this. Yes or no? So far, so good. You realize so far what I have done here? Right? Now, I'll just do one more step and then leave you independent with the problem. See, one of the results that I told you, NCR plus NCR minus 1, that's equal to N plus 1 CR, yes or no? Yes or no? Which means N plus 1 CR minus NCR is NCR minus 1. N plus 1 CR, NCR is NCR minus 1, clear? So this is like, if you call this P, if this is P, then what would this be? P minus 1, yes or no? So I have P CR minus P minus 1 CR. Coming back to this, N plus 1 CR minus NCR is NCR minus 1. So if I took N plus 1 as P, then N would be P minus 1. So I get PCR minus P minus 1 CR in a general sense. PCR minus P minus 1 CR equals P minus 1 CR minus 1. Yes. See, all of these are of the same form. PCR minus P minus 1 CR, PCR minus P minus 1 CR, PCR minus P minus 1 CR. So each of them would be like of the form P minus 1 CR minus 1. Yes or no? Right? Now with each of these, see what you can do. I want to leave you independent with this for some time. I'll move around in the class to see what you've done and see how much you can simplify, what you get out of this. right? With this for the time being unpaired with any term, right? So use this in each of these to see if you can get something good out of this. And then one more thing that you realize from here is 1, 2, 3 up to n minus 1. These are n minus 1 terms, and including this, there would be n terms. There would be n terms. You know what I'm saying? So start working on it. Simplification beyond this, and let me just go around and help you out. I want to leave you independent to simplify this expression, right? Stand by. See one thing, PCR minus P minus 1 CR would be P minus 1 C R minus 1, right? So using this result, see, all manipulation that's carried out is not done blindly. It's because you have a certain objective in mind. You know that you have to arrive at a certain thing. Keeping that in mind, manipulations are carried out. Now, okay, NCR minus n minus 1 CR would be n minus 1 C R minus 1. So this is going to be n minus 1 C0. And first of all, if I include this term, how many terms are there? N terms in all, right? So this n minus 1 C0 plus minus n minus 1 C1 by 2 plus n minus 1 C2 by 3 minus 1 to power n minus 2 n minus 1 3 n minus 2 divided by n minus 1. Yes or no? And realize that now this seems to match with this, because the term after this is minus 1 to power n minus 1, and you realize that NCN is 1, and NCN therefore is the same as n minus 1 Cn minus 1. So, yes or no? So then what I want to do here is I want to write NCN as n minus 1 Cn minus 1. Yes or no? So far so good. Yes or no? Now I need 1 by n common from these, isn't it? So I force a 1 by n out, because I have to establish that un minus 1 is 1 by n. So I force a 1 by n out of this. I force a 1 by n out of this. How about it? How many such terms? N terms. Yes or no? Right? Yes or no? See? If I took n common, then this is what happens. All the terms get multiplied with n. Now, let me convert into the raw format. Realize that PC0 is 1, PC1 is P, PC2 is P into P minus 1 by 2 factorial, PC3 is P into P minus 1 into P minus 2 by 3 factorial, and so forth. Yes. Right? This would be 1 into n. This would be 1 into n minus PC1 is P. So P is n minus 1. So this would be simply n minus 1. N into n minus 1. And 2 is the same as 2 factorial. This is PC2. P into P minus 1 into P minus 2 by 3 factorial by 2 factorial by 2 factorial, yes or no? And 2 factorial into 3 will give me 3 factorial. So PC2 would be P into P minus 1 by 2 factorial. So 2 factorial into 3 would give me 3 factorial. So this is n which was already there, n minus 1 into n minus 2 by 3 factorial up to n such terms. Yes or no? Yes or no? This is 1 by n, nc1. This is nc1, right? N is nc1. N into n minus 1 by 2 factorial is nc2. nc3 up to n terms. Yes or no? Right? What I do is, what's missing here is a minus nc0. To complete the spectrum, minus nc0 I add, subtract, and then I add nc0. nc0 by n then would come out. So that this plus nc0 by n and minus nc0 by n would cancel off. This realizes minus 1 by n, c minus c1 plus c2 minus c3. And now they would be 1 terms, up to n plus 1 terms. And then nc0 by n is 1 by n. What is this? C0 minus c1 plus c2 minus c3. In 1 plus x power n, put x equal to minus 1. You get this as 0, yes or no? So this will be 0 as you expected, and this would be 1 by n. So all along, like a hawk, your target should be to scoop a 1 by n out of it by brute force. So all manipulations carried with that intention in mind. Yes or no? Right? Are you clear about this? Huh? Oh, I didn't intend to. So un minus 1 is 1 by n. Then I have told you what after this. Put n equal to 2, 3 up to n and add vertically. Because we started the problem with that, because we predicted that. That was part of our prediction. Yes or no? And that's why we did all this. So I did the last part of the problem first and then discovered the rest. That is how we solve this problem. So this constitutes yet another premise towards heuristics or mechanisms of problem solving, that your ability to predict certain things and constitute a framework around it. Right? Are you there with me? I mean, at this point of time, putting these things, it might seem like little far-fetched, but if you are into it, if you dwell in it, you'll realize that over a period of time, you'll become very, very conversant with mechanisms of problem solving. After all, when a problem is solved, there is something happening inside the problem, which is the mechanism of a problem, which is like when you take one route, it converges to a solution. If you take another route, it will not converge to a solution. It means deep within the problem, there is a process that happens, right? Being able to identify the process, being able to predict the outcome is part and parcel of developing that problem solving skill innately, right? This is what you want to do. Yeah. Now, I did this problem in a little bit of an elaborate manner, but if you were in class 12, then I wouldn't have done this problem this way. I would have made life a little simpler. Now, I'll solve that problem yet another way, and you'll realize why I didn't do it that way, even to begin with. Why did I take you through such an elaborate method of solving the problem when it could have been simpler? Because even the blueprint that I adopted towards the problem, even though it took a very elaborate set of stages, it was very instructional. It was very instructional. It did send into you some semblance of an instruction and some semblance of another problem solving technique in general, right? But in any case, let me take you through another route, which essentially, like I said, I would have done if you were in class 12. In all these cases, like I've always told you, unambiguously, you start with the regular expansion 1 plus x power n. But now, in this case, since signs are alternating, I would start with 1 minus x power n. So that right in the first place, I have alternating signs at my disposal, right? So, 1 minus x power n would be c0 minus c1x plus c2x squared minus c3x cubed, and so on and so forth. Yes or no? That's 1 minus x power n. In 1 plus x power n, I've replaced x by minus x. How about it? Right? Now, in the required expression, I don't need c0. So what I do is, well, c0 is not required with this, I club it with this. I club it with this. So I transpose. I transpose so that c0 gets absorbed with this. c1, c2, c3 then are together, right? So at the very onset, I do this. c0 is 1. Realize that c0 is 1. So 1 minus x to power n. That's equal to c1x minus c2x squared plus c3x cubed and so on and so forth. See, if I integrate, this will give me c1 by 2. This will give me c2 by 3. This will give me c3 by 4. c4 by 5. But that's not what I need. c1 by 1. I need c2 by 2. I need c3 by 3. So it would have been so good if this was not x, but 1. Then on integrating, I would have got c1. If this was x, then on integrating, I would have got c2 by 2. If this was x square, then on integrating, I would have got c3 by 3. If this was x cubed, I would have got c4 by 4, and so on and so forth. Yes or no? So, well, it's up to me to make it that way. I can divide throughout by, alright. Let me divide throughout by x. So, c1 minus c2x plus c3x squared minus c4x cubed and so on and so forth. There's good enough reason for us to have done this, right? And then I integrate both sides. Zero to 1. Because when I integrate both sides from 0 to 1, this will be c1, c2 x square by 2 when I supply the limits, it will be c2 by 2, c3 x cube by 3 when I supply the limit 0 to 1, it will be c3 by 3, c4 by 4 x power 4 when I supply the limit 0 to 1, it will be c4 by 4 as is required in the right hand side, yes or no, on this side, right? So then, all this was done from 0 to 1 in order that I could get this expression in perspective. Yes or no? I hope you understand why I chose to do this, right? Is as expected minus C1 plus C1 minus C2 by 2 plus C3 by 3 and so on and so forth, which is the expression that we've been eyeing all the time, right? Now about this one, right? I have to establish that this is 1 plus half plus 1/3 plus 1 by n, right? Till this point, I could have done it with you guys and you would have felt absolutely at home, right? But beyond this point, to be able to deal with this is something that I would have done in class 12 because it required a property. It required a property. The property, in any case, I'll state the property for you right now. The property of definite integrals. Please take cognizance of this, which is a property that I'm going to use. And because of this property, I didn't go ahead with this simpler approach of integration. The property is 0 to a. We'll do this property in class 12. 0 to f of x dx is 0 to a. You can replace x by a minus x. You can replace x by a minus x. Integral 0 to a f of x dx is 0 to a. The x can be replaced by a minus x. This is a property of definite integrals that we'll do in class 12. And this property prevented me from going ahead with the solution that I'm proposing. But in any case, in class 12, you would have known this property. You would have used it like a billion times. Okay. And once you have this property handy, once you have this property, integral 0 to a f of x dx is 0 to a f of a minus x. This is what I'm going to use here. This is what I'm going to use here. That means, in this case, a is 1. So, and this is my fx. So, I'm going to replace x by 1 minus x. I'm going to replace by 1 minus x. Yes or no? Right? So, when I replace x by 1 minus x, 1 minus x, so this becomes 1 minus x, so simply x, isn't it? Replacing x by 1 minus x, 1 minus x, so that will simply be x, 1 minus x to the power n divided by this x also to be replaced by 1 minus x. This is the left hand side? Yes or no? Now, of course, life is simple because realize that 1 plus x squared, sum of this GP series is 1 minus x power n by 1 minus x. Yes or no? This is the sum of this GP series. Isn't it? Sum of this GP series 1 plus x squared up to x power n minus 1 is 1 minus x power n by 1 minus x, common ratio x, first term 1, number of terms n, right? So this then is 0 to 1, 1 plus x squared, etc. Clear? When I integrate this x, when I integrate 1, I get x. From 0 to 1 would be 1. When I integrate this, x square by 2, 0 to 1 would be half. When I integrate this, x cube by 3, 0 to 1 would be 1/3. When I integrate this, x power n by n, 0 to 1 would be 1 by n. See, you get this. This expression then is equal to this 1 plus half plus 1/3 plus 1 by n. Yes or no? Comfortable, right? And so then this of course is much easier than the other one that I did at the very onset, but then both are important. The first one that I did teaches you a lot of things which could be used at other places. This one for the sake of problem solving is simpler and better. But then to give it to a class 11 student is sometimes difficult because you're not familiar with properties of definite integrals. That's why, right? Then this could have been an approach for class 12. Is that all right or not? Have you all understood everything that I've said here? 20, part 2. A minus C1 into A minus 1, C2 into A minus 2, minus C3 into A minus 3, minus 1 to power n, Cn into A minus n. In this, anyone who solved this problem? Anyone who solved? You solved it? Good, very good. Anyone else who solved this problem? Obviously, you want to combine terms that contain A and terms that don't contain A. Yes or no? Terms that contain A minus C1 minus C2 plus minus C3 and so on and so forth. So A into 1 minus C1. So 1 could be written as C0, right? Minus C1 plus C2 minus C3, etc. These are terms with A. Terms without A are plus C1 plus 2C2 plus 3C3, sorry, C1 minus 2C2 plus 3C3 minus 4C4 and so on and so forth. These are terms that don't contain A, right? A, C0 minus C1 plus C2 minus C3 is 0. C0 minus C1 plus C2 minus C3 etc. is 0. This one is 0, yes or no? Right? I've given you this result. Now C1 minus 2C2 plus 3C3, that's also 0. I've also given you this result. I mean, just to 1 plus x power n is C0 plus C1x plus C2x squared plus C3x cubed Cnx power n. Differentiate both sides with respect to x. So that's n into 1 plus x power n minus 1. That's equal to C1 plus 2C2x plus 3C3x squared plus ncnx power n minus 1. Yes or no? Put x equal to minus 1 on both sides. Put x equal to minus 1 on both sides. You get 0 equal to C1 minus 2C2 plus 3C3 minus so on and so forth. Yes or no? So then C1 minus 2C2 plus 3C3 minus 4C4, that's also 0. So this whole thing turns out to be right. Simple. (22) Very simple. Because this is C0 plus C1 plus C2 plus Cn, that's 2 to the power n whole to the power 2. 2 to the power 2n is the left hand side, yes or no? The left hand side is 2 to the power 2n. And the right hand side, see, this is like 2n C0, PC0 plus PC1 plus PC2 plus PC3 plus PCP. That's 2 to the power p. Yes or no? PC0 plus PC1 plus PC2 plus PCP. That's 2 to the power p. Yes or no? So this will be 2 to the power 2n. This will also be 2 to the power 2n. So very simple. Do I need to explain this again? I don't mind it. I'll explain this. Yeah. See, if I expand 1 plus x power 2n, then what will I get? 2n c0 plus 2n c1 x plus 2n c2 x squared x cube yes or no? That's the expansion of 1 plus x power 2n. 2n c0, 2n, put x equal to 1 on both sides. So if you plug in x equal to 1 on both sides, then 2 to the power 2n is 2n c0 plus 2n c1 plus 2n c2 plus 2n c2n is what you get. How about it? Is that all right? So which is the right hand side and also the left hand side? Okay. Now what I want to tell you is